How's it going, everyone? This is Anthony with Precision Laser Instrument here for another TBC instructional video. Actually, we plan on doing a series of a few videos mainly highlighting the point clouds module inside of Trimble Business Center. It's been a minute since I've uploaded anything, and in that time we've actually got all the way up to Trimble Business Center version 5.7, which added a lot of nice features into the point cloud module. So what I'd like to do is be able to do a series of videos basically working left to right across the point clouds toolbar. This series is going to be focusing on Trimble X7 data, but pretty much all the tools and workflows will be able to be used with almost all of the Trimble scanners, SX10, SX12, TX series scanners, and the X series or X7, as well as some of these tools will be able to be applied to with Faro scanners as well, or any other point cloud file format. So in order to get this thing started, we're just going to grab one of our TDX files off of a Trimble X7, and I'm just going to drag and drop it in, just to more or less highlight the ease of getting data into here. So if I grab a X7 data, it's going to bring up this little option menu, and one of them, the only one that I currently have selected right now, is going to be colorize, uncolorized scan points, and also we're going to create the 3D panorama for the station view. I'm not going to create the panoramas for the media file, but those will spit out JPEGs of each one of the stations. So I'm just going to click this and hit OK and wait for the data to be imported. Alright, now the data has been imported. It's going to ask you immediately the projection definition, which is just going to be using a grid point at 1, which is going to be at 0, 0. So we don't need to worry about putting a false northing or a false easting in, so we'll just say OK. And here is our data. So this data had some issues with the registration in the field. So we're going to go through our first thing, which is going to be the register scans tool. But for those of you not aware, the first scan that you do, so if I go to this point 1, center of scanner on the tripod, is going to have a northing, easting, and elevation of 0, 0, 0, and depending on how you do your registration, so if you always set your registration to the previous, everything's going to be related to that. So scan 1 would essentially be the reference station that would never move. Now once you run through the registration, if you continue to use 1 as your reference, the coordinate of it will never change. But if whenever you're doing your automatic registration on the project, it could potentially move. Really not that big of a deal ultimately, but just so that you're aware. This particular project will be geo-referenced, and we'll go over that in another video as we move across this. But for where we're going to start, we're going to go under our Register Scans tab. Now, just to show where the issues are, in our Point Clouds tab, we can go into our 3D view, and if I go into the 3D view and orbit here, we can see a problem here on this roof line in between these two buildings. You can see right here there's this peak here, and then there's the peak here. Those two, those obviously need to be fixed. We can see the shape here is not quite right. I think there's another issue somewhere else, but it doesn't really matter if there's more than one. You know, I think right here as well, you can see this roof edge here, and the wall space isn't quite right. So there's several things here that need to be fixed. So there's a couple different ways we can go about doing this. Now with our X7 data, so we'll go under our register scans. Now, with our X7 data and also with our FLS, so the X7, the TX8, and the TX6 all use the TZF file format. And with that TZF file format and also with the FLS file format, we can do what's called plane-based registration. And plane-based registration is essentially an automated registration. It's the same sort of registration that's being used in the field with the X7. So you can use those features inside of here. The other one is the manual registration, which is what's called pairwise. And pairwise you can use with the FLS, TZF, LAS, the SX10, SX12, the RWCX file format. All those can be done within the pairwise registration. So if you import like an LAS or an E57, let's say you take something from Pix4D that's drone work, or from any other scanner out there, and you want to bring it into here to work with it, you'll have to use the pairwise registration, because Planebase is strictly FLS or TZF file formats. So this is relatively simple. The only thing here to keep in mind is you have reference stations and you have moving stations. Now for this particular data set, it really makes no difference which one I select to being which one. Usually you want your reference stations to be the ones that have the most shared data, or the ones that are correctly registered already. Or let's say that it's you are bringing in two different data sets. One of them is from an X7 from a georeference point cloud you had done previously, and you added a few more scans a little bit later on, and you brought those things in. They would not be georeferenced. So you would want your reference stations to be the ones that everything is moving to, hence reference and the word moving. So pay attention to which selections you have in each one of those menus. If you do make a mistake, you can ultimately ungeoreference data that you've already done and moved it into to an improper location. Not a big deal. You can always undo it, but it's just one additional step that you have to take. You'll also notice inside of here as well, where it says leveled, it's going to say yes. The X7 does automatically level itself. It's what the little light indicators are all about. But there are places where you may need to do a scan where it can't be properly leveled for one reason or another, or maybe you're trying to lean it around a corner or over an edge of something. It will scan unleveled, and it will tell you that it's not leveled by being here. And being leveled or non-leveled really doesn't matter all that much, but a non-leveled scan cannot be used as a reference, because if that scan is leaned in a particular direction, then and use it as a reference, then the data that's already leveled could potentially lean over in that same orientation. So non-leveled scans cannot be used as reference. So keep that in mind. You can see here our reference stations. We have several here, but then we skip several, and then we're back to 28 and 29. So it goes 11 and 12, 28 and 29. Then over here, we have some moving stations that have several scan stations, some that are independent of this. So essentially what it's going to try to do is it's going to take these that it believes is already registered together and show you, or move those ones to line up better with these. And then 17 and 18 are going to come over and merge into this as well. So apparently this is going to be 13, 14, 15, and 16. And this is going to be 17, 18, all the way to 28, because there's no individual ones here. And we can actually verify how well these stations were registered to begin with. So if we close out of here and we go to our home tab and go into our filter manager, and we go to our individual scans, we can see them here and numbered. So I can turn off all the scans and maybe go 1 through 11 and turn just those on and see how they stitch together, which they look perfectly fine. So we can turn on 12. 12 is obviously working around this corner here. All looks good. 13. And I think this is where the problems more or less start as soon as we come around that corner. So it kind of correlates to what we were seeing here in our register scans option. We get all up to 11 and 12, so 13 is where things start going bad. And then if I turn on 28 and 29, which are going to be on the other end here, even these I don't think completely are completely right either. You can see this one window sort of sticking out here, so that's not even correct within itself. So if that is the case, then what we can actually do is unlink 28 from the overall registration, and as well as 29. So turn those two off, and that leaves us with a presumably good data set here to start off with. So if we wanted to, we could go into pairwise and manually register these two in, but what I'm going to do is I'm going to uncheck these two. I'm going to register 28 and 29 just to sort of show how the process goes. So our reference station is going to be 1 through 12, and we're going to try to automatically register 28 and 29. And the reason why I'm only doing these two is strictly because these other ones are going to take a little bit of time, so I'll probably stop the recording, then restart it once we come back and see what the results are. So for 28 and 29, we'll more or less try to do these live. You'll just click automatically register. You'll see down here we have a progress bar that's going to go, and then once it figures out where those two fit, it will give us a registration report. Okay, so those ones are complete. It's going to ask you, do you want to generate a registration report? And this is your only opportunity. You cannot generate this report at a later time. Not necessarily true. We can get every single time we run a registration or run a refinement, we can get a registration report. But we'll just say yes, and then see what those results ultimately look like. So basically what the report is going to show you is the station number, how it links to the previous one, and what its confidence level is that it's going to go. So obviously green is good, orange is not quite sure, and red is obviously its confidence level is relatively low. Those things are going to fit. But that doesn't necessarily mean that like 12 is, or that 8 is bad in 12, or that 8 is going to be a troublesome station, because 8 is probably good in other stations that we did the scan in. The main thing with any one of these things is just having the necessary overlap from one scan to the next. So not saying these ones are going to work out perfectly, but we're going to take a look at this small subset. So we'll turn 28 and 29 back on again, and we can see they're a lot better placement than what they were previously. However, they are still not exactly perfect. I think I see a little bit where it's sort of bulging out away from the wall. Now, some of these things can be fixed in the refinement, but we definitely don't have an obvious error like we did previously. Now, again, when you're out in the field and using an X7, and I'm going to keep referencing back to the X7 because it's sort of the only one in its class as far as field registration is concerned, you need to be mindful of how you have your X7 set up to register at every single station, because in the lower right-hand corner in perspective, you can choose which station it's registering to. By default, it's always going to be set to the last. So if I go to move from 28 to 29, 29 is going to register back to 28. Well, if you look at this spacing that we have between these two, 28 may not be the best station for 29 to register to. It may be better off with 3 or 2. So be mindful whenever you're moving it around, not always having it set to the default setting. Make a little bit of a judgment call as to which station you want it to register to. Because the perspective software is great for letting you see the amount of coverage you have on a particular site. It's not doing a full-on registration because it's only registering to a previous station. So the more scans you do, the more error can sort of compound if you're not paying attention to where another station was that may be better suited to register to than the previous one. I generally will pay attention to where my previous stations were and maybe make some adjustments and changes. But my main goal with the X7 is to get as much data collected as humanly possible, paying attention to my overlap from one station to the other to know that I can get the registration done in post if needed. I usually try to make sure that my registration's like 80-90% there whenever I leave the field, but knowing that I can finalize everything inside of here because I have the more processing power in my laptop than obviously I do in the tablet whenever I'm out in the field. So what we're going to try to do here is I'm going to register these two other groups into this, see what kind of results that I get, and I'll bring you back whenever this is complete. So I'm just going to click automatically register, and I'll bring you back as soon as this is done. Okay, so we can see that 13 and 14 did not, or this group of 13, what would it be? 13 through 28 did not register into the main cloud, but let's verify. So if we turn off all the stations and we turn on 1 through 13, let's just verify that this is properly stitched together. And one way that we can do that is just by running, basically verifying by using our plane manager. So I'll use the plane manager. I'm going to create a new plane that's perpendicular to the elevation axis, and I'm going to run it right through this roof line here. So now if I go into my cutting plane view, and actually I'm going to switch this to scan color. I'm going to look at my data and see what issues I may have. So we can see where the plane is going, and I can slide this up or down. And what I'm looking for is any sort of obvious registration failures. And we can see we have something going on right in here. So even though these ones are saying that they're registered together, they're not done properly. So what I'm actually going to do, if you do run into this, you can try to do it by running the registration a few different times, but I don't actually like doing that. So what I'm going to do is I'm going to unlink all of them. Okay, and I'm going to choose the second group. So I'm going to turn these off, and I'm going to go 14 through 27 and turn those on. Turn my cutting plane view off. I'm going to visually go through and look at the data and see how it looks. And I'm not seeing any glaring or obvious issues with it so far. Maybe a little bit. So this data set doesn't look, or at least on this side, doesn't look quite bad. So what we can try this instance is move our reference stations to being this 13 through 27, and then register in these ones. All right, so running at that time, everything across here is green, but you see we have some individual stations here that need to come over. It mainly looks like 1, 2, and 3, 4, 5, 6, and several other ones along those lines. We're going to have to manually register those ones in. So regardless of what I do and what goes on with this project, we're going to have to do some pairwise registration. And again, this is just a very realistic thing that can happen out on a site that you may have to do a lot of manual work. So we're going to go into our pairwise now. And we're going to get some of these issues corrected. So our reference stations, I'm going to make it be our main group, which is going to be this 13 through 27. And we are going to check and see if there's any relatable data for 8, which there is. We have this entire side here to kind of work with. So we're going to switch this back to being true color up here on top. And we're going to look at our data. So we can see it's the side of the building. We come over here, we can look at that exact same side of the building. And we're just going to click this wall and this wall, and hopefully the two will come in together the way they're supposed to. And that definitely looks way better. So we'll go ahead and we'll just hit the optimize pair registration. I usually do this after selecting a point, but at the end of all this, we're going to run through the refinement anyway, but I like to just do this to make sure we get this just right from the start. All right. Decent residual error, we'll add to reference. Okay, now we have 1, 2, and 3. And we can see how these ones relate. And honestly, that does not look, nope, our fence line's off a little bit. So we're going to say, before I even select anything, I'm just going to try to optimize pair. You can see we lost the double fence line and lost the double fence line, and everything sort of makes sense now. Just going to go check a few areas. Everything looks pretty good, so I'm going to add that to reference. It's a big chunk of data that's going to move up for me. And the last data set is going to be here. So we already have 1, 2, and 3 already done. So we're going to select our 2 common points here. So we're going to choose the peak of this roof right here as being the same. And then we're going to go over to the other side of the building. I'll go to this little gazebo thing. We'll click on this doorway. And hopefully that's enough to make these 2 stitch together the right way. And I think that's it. Doesn't look half bad, or maybe a little bit of misalignment in some places. But everything is really close. The major busts seem to be gone. So what I'm going to do now is I'm going to hit add to reference. And I'm going to go into where we have our refinement. So the registration does not have to be absolutely perfect whenever it comes in. It just needs to be close so we can, in order to get these things stitched together. And I look around for the major errors. Like I said, this roof line here was kind of a mess, and it seems like we got that. Fixed. We can see nice straight lines throughout between the actual building itself and the drip edge along the roof end. And we're just kind of work around the building, just verify there's no doubling. Single fence line, driveway looks decent. Tree locations. The other place to look is like poles, to verify you don't have any doubling on poles or power lines. I noticed these columns right here looked a little bit, maybe like they were doubled. So in order to get those fixed, what we're going to do is what's called a refinement. So plane-based registrations, automated, works most of the time. Pairwise rather would be your next overall solution. That allows you to manually stitch them together. And then after, regardless of anything, even if you brought in a point cloud out of the field that was dead on, I still like to run the refinement just to verify. So in this case, I'm going to run the refinement, and I am going to fix a point cloud here, and I'm going to choose probably 28 or 1. More most likely 28 because it seems to be bridging the gap in between the two main scan groups. So I'm going to say 28 is going to be fixed, and then I'll choose to refine the overall registration. So like I said, in the field, whenever you're scanning, 1 is going to register to 2, 2 is going to register to 3, so on and so forth. So it's only doing 1 scan at a time. Whenever you're doing your plane base, it tries to look at every scan versus every other station. And the refinement is doing exactly that as well, as it's saying, okay, your registration's good, but let's take a look how every single station overlays and matches to the other one. So it's going to do 1 versus the remaining 29, or 28 rather, 2 versus the remaining 28, and so on and so forth. And gives you an overall registration report or refinement report, letting you know what your true cloud-to-cloud error is and what your overlap is for the entire project. Alright, so the refinement is complete, and we can take a look at our overall registration report and just see what we get. So here's our cloud-to-cloud error, 27 to 1, a little bit lower confidence level. Overall, looks like everything went through. Take a look, and we'll hit close on our refinement. And zoom in on those columns, and you can see that any sort of doubling that we had there has been resolved in the overall refinement. And that is our point cloud registered. That's it for this video. Next time we'll be going over georeferencing. That'll be released next week. Any questions, feel free, leave a comment, and I'll see you in the next one.